This is section 6.6 part 2. Let's continue with this problem. In the last video I was saying that negative 8 plus positive 7 is negative 1, so that checks out. So we're going to set each of these equal to 0. Okay, so this will be 8 over here, and this will be negative 7. So like what we were talking about in one of the previous examples, nothing I can use for x. There's no value x that I can use that will make this one right here a negative value. Even if I have e raised to negative 3, well, that's just 1 over e raised to 3 squared, so that'd be 1 over e cubed. I said squared, it should be cubed. That's still going to be a positive number. So this one is an extra answer. Can't have this one. Okay? Now this one over here, we can apply the natural log to both sides, and it will cancel out the e in the natural log here, so I'm left with just the exponent. Okay, and the exponent is x in this case, so x is equal to the natural log of 8, and this is the answer to this equation. Okay, let's look at this one, and we're going to solve for x. So I'm going to divide by negative 3. So I have negative 2/3 equal to e raised to x. Just like in that last video, there's no value of x that I can use that will make this a negative. It will be a very, very small fraction, or very, very large number, but it will still be positive. So no solution is our answer for this equation. Now let's look at solving log equations using the definition of logarithms. Okay, so if we have log of base b of s equal to c, we can change that to an exponential function. So b raised to c, or the base raised to what it's equal to, and then that's equal to what's inside. Same thing here. Okay, so if we look at this one right here, the first thing I'm going to do is I'm going to try to combine them. So I have a log of base 2, so I can combine them. They have the same base. And there's a plus sign between them, so this is going to be log of base 2. 2 times 3x minus 5 is equal to 3. So that's log of base 2. That will be 6x minus 10 is equal to 3. And now what I'm going to do is 2 raised to 3 is equal to what's inside. So 2 raised to 3 is equal to 6x minus 10. Well, 2 raised to 3 is just 8. Okay, and then I'm going to add 10 to both sides. So we're going to have 18 is equal to 6x. Divide by 6. So x is equal to 3. And that will be my final answer. Okay, let's look at this one right here. Same thing. 2 natural log of x plus 3 equals 7. I'm going to move that 3 over. So 2 natural log of x is equal to 4. I'm going to divide by that 2. So the natural log of x is equal to 2. Now remember, we can write this as log of base e of x is equal to 2. So e raised to 2 is equal to x. So e raised to 2 is equal to x, and there's my final answer. Okay, let's try this one. 2 natural log of 6x is equal to 7. I'm going to divide both sides by 2. So natural log of 6x is equal to 7 over 2. Again, this is log base e of 6x is equal to 7 over 2. So e raised to 7 over 2 is equal to 6x. So e raised to 7 over 2 is equal to 6x. And I'm going to dividing by 6 and multiplying by 1/6 is the same thing, or 1 over 6. So that's what I'm going to do. So you could see it as 1 over, it should be 6, over 6e raised to 7 over 2 equals x, or you can see e raised to 7 over 2, and that's divided by 6. Either one of these, they're the same, it's just a different form. Okay, let's try this one. Log of base 7 of x is equal to 10. I'm going to divide both sides by 5. So log of 7 of x is equal to 2. 7 raised to 2 is equal to x. 7 times 7 is 49. So our answer is 49. Okay, solving logarithm equations using the one-to-one property for logs. Okay, so if you have log of base b of s is equal to the log of base b of t, that's the same thing as saying s is equal to t. So let's look at this right here. Notice both of these are natural logs, so they both have a base e. So all I have to do is set what is inside equal to each other. Okay, so I'm going to try to factor this, so I'm going to move everything to one side. So we'll have an x and an x. It looks like a 3 and a 1. Negative 3 times 1 is negative 3, and negative 3 plus 1 is negative 2. So it looks like we have x is equal to 3, and x is equal to negative 1. Okay, now when I plug back these into the original equation, even though this is a negative x, when you plug it back into the original equation right here, it will give you a positive value within the parentheses. So they're both the answers here. Okay, for this one, log, log, and log, so all of them have base 10. So I can first use the properties of logs to combine. So I have the log of base 10, so I'm just going to write log. And I'm going to have x plus 3 divided by x is equal to log of 74. Okay, so now I can just set what's in the parentheses equal to each other. Okay, so we can put this over 1 and we can cross multiply. So this would be 74x is equal to x plus 3. I'm going to subtract x from both sides, so this will be 73x is equal to 3. Divide both sides by 73. So x is equal to 73 divided by 3. Whoops, I switched that around. That should be 3 over 73, and that's going to be my final answer.